So we're going to practice launching a load balancer, but first we need to send traffic to something. So first we're going to launch EC2 instances. So I'm going to go into launch instances and I will launch 2 instances. So on the right hand side, I can say 2 instances. And the name is going to be my first instance. We'll rename the second one when it comes to it. We're going to use Amazon Linux 2 on this architecture. We're going to use a T2 micro. And then we are going to proceed without a key pair because we don't need SSH capability. We can use EC2 Instance Connect if we ever need to. Then for network settings, we can select an existing security group and we will use the Launch Wizard 1 security group, which allowed us to do HTTP traffic and SSH traffic into our EC2 instance. So that's perfect. We're going to use the basic storage. And for advanced details, I will scroll down and I will add some EC2 user data. And to do so, I'm going to copy what I have here and paste it here. So this will just launch the EC2 instance the same way we've launched them before using this EC2 user data script. So let's launch our 2 instances. And now we're going to view all instances. So I'm going to rename the second one my second instance and save. So let's wait for these instances to be ready. So my EC2 instances are now ready. I'm going to copy the first IPv4 address and paste it, and I will visit the URL. And as you can see, I get a hello world from my instance. So this is great. And then I can go to my second instance right here. I will copy again the IPv4 and then paste it, press enter, and I get a hello world again. So as you can see, 2 instances give us 2 hello world, and the last part is changing. And so what we'd like to do is to have only one URL to access these 2 EC2 instances and balance the load between them. So for this, of course, we're going to use a load balancer. So let's scroll down and look at load balancers. And here you can create a load balancer. So we have different load balancer types. And in this demo, we're going to only look at the application load balancer. But you need to understand the difference between the ALB, the network load balancer, and the gateway load balancer. So for the application load balancer, as you can see here, it is for HTTP and HTTPS kind of traffic. For the network load balancer, it's going to be on the TCP and UDP protocol, or TLS over TCP. And this is something you're going to use when you need ultra high performance. That means millions of requests per second while maintaining ultra low latency. So this is a very high performance load balancer, this one. And then finally, the gateway load balancer right here, as you can see, it's used for security, for intrusion detection, for firewalls, and so on. So it's to analyze the network traffic. When it goes to the classic load balancer, by the time you watch this video, this may be gone because the classic load balancer is going away. And so therefore, I'm not going to discuss it and touch it. Okay, so let's focus on creating the application load balancer. So I'm going to call this one Demo ALB. And if you wanted to read about how load balancing works, you can read it here, but hopefully the previous lecture was enough for you. So the scheme is internet facing and the address type is IPv4. For network mapping, we need to decide where to deploy the load balancer and how many availability zones. So let's deploy it in all of them. Great. And then we need to assign a security group to our load balancer. So it turns out that I'm going to create a new security group for it. And we need to only allow HTTP traffic. So I'll call it demo SG load balancer. Allow HTTP into load balancer, into ALB. And the inbound rules is going to allow all HTTP from anywhere. Okay. And the outbound rules are fine. Let's create this security group. So it is now created. And I can go back in here, refresh this page, choose my demo SG load balancer, and remove the default security group so that I'm only left with one security group. So let's scroll down, and we are under listeners and routing. And so we need to route the traffic from HTTP on port 80 to a target group. And a target group is nothing more than a group of my EC2 instances that were created. So for this, we need to create a target group. So let's click here to create one. And the basic configuration tells us that we want to group instances together, but you can see you have other options. So we want to group instances together, and I'll call this one demo TGALB. The protocol is HTTP on port 80. You have different options, but based on the option you choose, is going to be a target group for a different kind of load balancer. So we'll keep it as HTTP on port 80. The version of HTTP is 1, so we'll keep it as 1. The health check is good, and then let's click on next. And then we need to register our targets. So we're going to register both EC2 instances on port 80, and let's include them as pending below. So now my instances are registered, and let's create this target group. So it's created, and now I need to refresh my page, and actually I had created one before. So the one I want to use is demo TGALB. So this target group is created, and it's linked to the listener on my load balancer on port 80. So now I'm good to go, and I can go ahead and create my load balancer. So I'm going to click on View Load Balancer, and I'm back into this page where I can have a look at my load balancer. And right now, it is in the provisioning space. So we need to wait until it is provisioned. So my ALB is now active. It's ready. And as you can see, there's a DNS name available for me. So I'm going to copy this, paste it in a new tab, and through the application load balancer, I'm able to get a hello world. But the cool thing about it is that if I refresh this page and keep on refreshing it, then as you can see, the target is changing. That's because my application load balancer is actually redirecting between both my EC2 instances, which is very cool. And that's the proof that load balancing is actually happening. How do we know? Well, if we go to our target group, this one, and we look at the targets of my target group, as we can see, they're both healthy. That means that the application load balancer through the target group is going to send traffic to both of them, one after the other. And the target group is very smart, because if I take my first instance, for example, and I stop it, through this, what we're doing is that we're stopping our EC2 instance, and so therefore it's going to be unhealthy because it cannot respond anymore to the traffic coming in. And so if I go in my target group, maybe I'm too fast, let's see, and refresh, so I will wait about 30 seconds. And now, as you can see, the first instance is unused because it's in stop state. And so therefore, if I go back to my application load balancer and refresh, the only response I'm getting for this instance is that one instance that is still up and running. This is the power of using load balancers, because they know when the targets are healthy or not healthy. And so this instance is stopped, but of course, if I recover it, if I start it again,
That means you can use this class from Java and from Kotlin the same way, independent of where it was declared. The use looks identical. Here's how you can use the Kotlin class person from Java code, creating a new person object with the name Bob, who is a student until he graduates.
Listing 2.5, using the person class from Java.
Note that this looks the same when person is defined in Java and Kotlin. Kotlin's name property
And now, as you can see, the first instance is unused because it's in stop state. And so therefore, if I go back to my application load balancer and refresh, the only response I'm getting for this instance is that one instance that is still up and running. This is the power of using load balancers because they know when the targets are healthy or not healthy. And so this instance is stopped. But of course, if I recover it, if I start it again, then it's going to boot up and is going to create the service. Behind the scenes. And so let's wait for the instance to be started. And hopefully we'll see it again as being healthy in our target group. The instance is now up and we are in the initial health status, as you can see. And now we are in a healthy status. So the instance was deemed healthy. And so therefore, if I go back to my application balancer and refresh, as you can see now, the hello world is coming from both instances. So that's it. We've practiced load balancer. We created one as well as two targets in the target group. I hope you liked it, and I will see you in the next lecture. So let's have a look at a few more advanced concepts for our load balancer. Number one is around network security. So currently, we access this load balancer through a security group here. This is my load balancer security group. And then we access our EC2 instances through their own security group. So right now, if I look at the public IP and access it, as you can see, I can access my EC2 instance directly, or I can access it, of course, through my load balancer. But it may be preferable to only access my EC2 instance through my load balancer. So how do we do this? Well, under instances, let's go for security group, so right here. And we're going to look at the launch wizard. one security group. And in here, for the inbound rules, we're going to edit them. And we're going to look at the HTTP rule. Right now, we allow everything from everywhere on this security group. But what we want to say is that no, the only traffic allowed into our EC2 instance should be traffic coming from the load balancer. So how do we change this? Well, let's first delete this rule. You have to first delete it, and then you add a new rule. And so again, we want HTTP. But this time, instead of having a CIDR block, you can scroll down and you can see that you can have security groups in there. So the security group we want to allow in is the security group of my load balancer. So if you just type load as well, it's going to filter the list. So then you select the security group of the load balancer. And the effect of this is that if we save this rule and have a look at it, now if we have a look at our EC2 instance directly, and I refresh this page, as you can see, it's timing out because it's like not being able to access the instance because I'm not allowed to access directly the instance. But if you refresh the load balancer, well, the load balancer can still access my instances because in the rule that we have created in our security group, we allow inbound coming from, if we have a look at here, we allow inbound coming from the security group of the application balancer. So here we have tightened network security. The second thing I want to show you is around application balancer rules. So currently, if you go into this ALB right here, and we go under listeners and I click on it, so as you can see, I have my listener right here. There are some details over it. And then I scroll down and we have the rules listener rule. So here we can add some rules. So we have the default one right now, which is saying that, hey, for every request, send it to my demo target group for my ALB. But we can add rules and make it as complex as we want. So this one is going to be a demo rule. That's the name I want to give it. And next we need to add conditions. So conditions is what do we want to filter in terms of requests for this rule. So do we want to look at host headers? So for example, have a look at, for example, if we are on the star.example.com or myapp.example.com or whatever you want. Path is for the path. So we'll use /error and saying, okay, if in the path we have /error, then this rule should come in. We can also have the HTTP request method to be get or post or whatever you want. You can filter and condition based on the source IP. And then you can have query string and HTTP header as well. So quite a lot of different possibilities. But for now, I'm going to use path, and the path is going to be /error. Okay, confirm. So we can add multiple conditions if we wanted to. Right now, in the rules limit, you can see the types of limits you can have. So let's click on next. We have one condition that's enough. And then what is the action? So once we match on the condition, what do we want to do with it? Do we want to forward to specific target groups? For example, if you had more than one target group, then we could define one or more applications based on path or based on host domain. Or we can redirect to a specific URL, for example, with the URI paths. Or full URL. on the protocol HTTP or HTTPS, and then a specific status code, and then as well customize the host, the path, and the query. Or we can return a fixed response, and this is the one I'm going to do right now. So we can say, hey, 404, it's not found, so not found, custom error. So this is what we're going to return when we go to /error. You'll see in a second that will make more sense to you. Then what is the priority of this rule? So right now it is pending. And so we have rules, and we can have maybe 100 rules in here. So we can define priorities, and the 1 is going to be the highest priority. 5 is going to be a bit lower, up to 50,000. So of course, based on, like, for example, if a condition is matched by multiple rule, is the rule with the highest priority that will win. So we're going to use priority of 5 just to give it as an example. And now we can see both our listener rules. Let's click on next. Everything looks good for this demo rule, and it has been created. So as you can see now, we have 2 rules, the default rule and the demo rule, and they're here. And you can add more rules if you wanted to. Now let's test it out. So if I go into my load balancer detail, look at the DNS name, copy it, and add /error, then this is going to trigger my rule. And the result is not found, custom error, which means that, yes, indeed, this request was matching the path pattern of /error. And so therefore, 404 and text plain was returned. So, okay, that's it. I hope you liked it. And I will see you in the next lecture. So now let's talk about the network load balancer. So it's a layer 4 load balancer, and therefore it allows you to deal with TCP and UDP traffic. Okay, this is lower level. Layer 7 was HTTP, and layer 4 is going to be TCP and UDP traffic. So these work for the network load balancer, and therefore when in the exam you see UDP, think network load balancer or even TCP. Okay. Also, on top of it, the network load balancer is really, really high performance, and therefore it can handle millions of requests per second, and the latency compared to the application load balancer is lessened. That means you get around 100 milliseconds versus 400 milliseconds for the ARB. Now, another specificity of the network load balancer is that it only has one static IP per availability zones, and you can assign an elastic IP to each AZ. So this is very helpful when you need to expose your application with a set of static IPs, and this can be elastic IPs. So when the exam you say, hey, your application can only be accessed within 1, 2, or 3 different IPs, then you need to think about the network load balancer as an option. So if you see extreme performance, TCP or UDP, or static IPs, think network load balancer. Now, using it is not included in the AWS free tier. So let's have a look at how that works. So it works very similarly to the application balancer. We create target groups, and then the network balancer will redirect to them. So we can use, for example, the TCP traffic, or for example, in the backend HTTP, but still in the front end use TCP. So what about the target groups? This is the important part. So the target groups can be EC2 instances. That means that your network load balancer can redirect to your EC2 instances and send TCP or UDP traffic to them. But you can also register IP addresses. And these IP addresses, when they're hard-coded, and they must be hard-coded, they must be private IPs. So why would you do this? Well, you can, of course, send the private IP of the EC2 instance that you own, but also you could use the private IP of a server that you have in your own data center. And therefore, both of them can be fronted by the same network load balancer. And it's also possible for you to have a network load balancer in front of an application load balancer. So in that case,
You know that feeling when your alarm clock wakes you up at 6 a.m. and you have to go to work again because you didn't die in your sleep? Well, you're not alone. 80% of professional developers know this feeling, according to the 2024 Stack Overflow.
Should we add a customer to you? So this is
endpoint with some JSON data, it's fine.
oh, that's right. Gosh, I said monads.
Is why can't we just proactively compile the whole thing? I don't know if I can, but it's the
It's Duncan. Hello, I'm Dmitry. And this is refactoring to expressive Kotlin. I feel it only fair to warn you that this talk is not entirely as built. We discovered very quickly that 45 minutes is not long enough to cover scope functions, extension functions, purity versus side effects, cohesion, tiny types, and domain-specific languages, at least not while live refactoring. So if you are here to learn about DSLs or tiny types or actions versus calculations, then you may choose to leave now. Tools and techniques for Java to Kotlin migrations is on in Auditorium 15. And I trust that the Google team is going to be plugging the book that I wrote in that price called Java to Kotlin and Refactoring Guidebook. So instead of broad, we decided to go deep, looking at what we to leave now. To learn about DSLs or tiny types or actions versus calculations, then you may choose to leave now. Tools and techniques for Java to Kotlin migrations is on in Auditorium 15. And I trust that the Google team is going to be plugging the book that I wrote in that price called Java to Kotlin and Refactoring Guidebook. Migrations is on in Auditorium 15. And I trust that the Google team is going to be looking at what we can learn about expressive Kotlin by looking at a simple class. So today, Dmitry and I will attempt to pair program at a small desk on a huge stage whilst arguing about code in front of a frankly terrifyingly large audience. Slide. I must warn you, most refactoring sessions at conferences don't go far enough. The following session, on the other hand, goes too far. Code.
Should we?
Code.
Okay.
You see, I can't see that for the glare. Never mind. We'll huddle up.
Okay.
Okay, so this is the class we're going to be looking at, dbconfig. I suppose probably, like in a session on expression, we should have called it database config, but I think you will get the gist. What do we see about this, Dmitry?
Well, there are a few fields, like secondary constructor, one public function, one private. It looks kind of normal.
So it's got state, and it's got operations, and they're just operations on that state, and there's methods, yeah?
Yeah.
Yep. And, but the methods don't change the state, it's immutable?
Yeah.
Okay. And those operations are just conversions, really, to other types, as far as I see. So where shall we start? Down the bottom? I mean,
Sure.
Yeah, we'll start right at the sort of inside. So we have this method called Hikari data source. And I've been doing some research into the English language, because I wasn't taught that, because I'm English. So Hikari data source is a noun, and a noun is a word used to identify a class of people, places, or things, or to name a particular one of those.
It's like a compound noun, the three words, right?
Oh, it is, yes. So source is a noun, data is a noun, data source is a compound noun, and Hikari is apparently Japan's leading manufacturer of fish food, and recognized globally for its exceptional quality.
Did they pay you for that?
Yeah. I think we may be sponsored by water. So often we name methods after operations, like we say load or save or render actiony things. And those are verbs. And again, I've been looking it up. A verb is a word used to describe an action, state, or occurrence. They're sort of doing words.
So to be clear, you say method, you mean function in a class, right?
Yes.
Yeah.
Yes. But Hikari data source is it's a method and it's a noun, but is there a verb missing?
Okay.
So we might call this what?
I don't know. Get, that's more Java way.
No, because it's not a property.
We just got rid of it, right?
Yeah, no.
Create?
Create. Okay, so I like create. I looked that up as well. Create is bring something into existence, which is true. We're bringing something into existence. But fundamentally, like almost all of our Kotlin code brings something into existence, so maybe that's not specific enough.
Should it be a? Like that's more like English.
I mean, yeah. How about convert to Hikari data source?
Okay.
Because I think that's what we're actually doing here. And I looked up convert, and that is change the form, character, or function of something. Interestingly, we're not actually changing the DB config because we can't. We can't change its type. So we're really sort of returning a converted version of it. So now we've got here I mean, I think convert is implied.
So, yeah, but just to be clear, I guess what you're getting at, like dbconfig is the subject of this, like a sentence, right? And then functions are kind of verbs, and we're missing a verb, but now we added it, and we think it's a bit redundant, so you say do this?
I mean, personally, I don't feel I need the convert. The to Hikari data source is enough for me.
Yeah, I think like convert is implied as a verb.
Yeah. Okay, so we've implied convert, we've got to Hikari data source, and that, I think, is quite a bit better than just the noun. So previously we had Hikari data source, and now we've added to Hikari data source. And I'm going to say that that is more expressive. And I looked up expressive, and it says effectively conveying thought or feeling. And you might ask, why do we want to be expressive? And I think our answer is, well, I mean, why would we want to not effectively convey thought? But the sort of thread we're pulling on in this session is that humans are brilliant at understanding natural language. And natural languages are brilliant at being understood by humans. And that's not accidental because there's been 200,000 years of co-evolution. Natural language has shaped us, and we've shaped the natural language. And almost, I think you could say, natural language is pretty much what it is to be human. It's what differentiates us from things without natural language.
It's probably the longest rename of the function in history.
We're not finished yet. Buckle up. So, we've added, the goal is, I suppose, like, how can we write Kotlin so that our natural language circuitry helps us quickly understand what the code is doing, rather than having to, like, parse the files like a compiler and run the code in our head. But we can't write in natural language because it's not specific enough. If it was specific enough, we wouldn't have lawyers. We can ask ChatGPT to do things for us, but I think it only really pretends to understand. So until computers get good enough at understanding what we mean and then negotiating, we have Kotlin and computer languages that are the way we express what systems do, and we have natural language, which is the thing that we really, really want to be reading, I think. Okay, so by adding one tiny word, we have more obvious intent. And the tiny word we added was...
Oh, we didn't.
No,
So
no,
you
not
mean
that one.
something like this.
No. Back. He's keen.
Right.
So we added to. Yes, thank you. And I looked it up, and to is a preposition, which, again, I'd never learned. A word expressing a relation to another word or element in the clause. So prepositions give us a direction, and I think it's that direction that's made this readable.
Oh, there are other prepositions. I see like
Yeah.
as.
Oh, yes.
Why not as?
I don't think this is an as, because as to me implies that is the same thing we're looking at, just in a sort of different view.
Okay. Sounds like it's used in standard library, right? So.
I mean, we have some, we have like this variable as string. We have casting, that's an as. But again, we're not changing. changing the identity of a thing, we're saying, give me a different view of it.
Okay.
Okay, so adding direction has made the code more expressive and has managed to imply the verb. If we look at where it's called, though, there, like data source equals to Hikari data source. And my question is, well, what to Hikari data source? I mean, I can obviously at this point see that it's there, but as Dimitri is pointing out, it would be nicer if we said this to Hikari data source.
I'm not sure I would actually do it on the project.
You see, I would. I think what we were missing was a subject. And the subject is a noun or pronoun representing the person or thing that performs an action or verb, or that's affected by the action. So it's the thing we're doing with, really. I mean, if the verb is doing. That also brought up pronouns. So what's a pronoun? A pronoun is a word that can function as a noun phrase used by itself and that refers to either the participants in the discourse or to something mentioned elsewhere in the discourse. So pretty much, it's a word which stands in for another noun that we've already mentioned.
Should we use I, like, instead of this? Like, like the class. Default I?
Well, interestingly, I mean, there was a convention at one time, wasn't there, for naming properties my something, and if it was my something, it would be I, yes. So there is a special pronoun in Kotlin, and that special pronoun is this. It's the instance of a class processing message, or it's the receiver and extensions. And this is a lovely because they are, we can leave them out. They're implicit, but we can also put them in. So if it helps to make code readable, we'll put them in. And so now we have our data source is this to our data source, and I prefer that, you don't.
Yeah, it's fine. I'm happy to leave it.
You're only young. Okay, so the preposition to has told us the direction. But what if we reverse the direction?
So from somewhere.
Well, so let's just try putting let's put the this at the other end. So we'll put it inside, we'll make it the parameter, I guess an argument on the outside. And then, wow, you're quick, but slow down just a little tiny bit. So at this point, we've got a this at both ends. We don't need a this at both ends now, so we can take out the first one, I think. Yeah, that'd be nice. Because this is, they're implicit, that's fine. And now we've got two Hikari data source, and Dimitri is trying to edit it properly to make it read nicely. And so Hikari data source from this, that reads as well. And nicely now, we haven't had to sort of bend and put the this in that we didn't have to put on one side, so we can swap. We can do one way or the other. So we've moved this to the other end of the phrase. We've made to into from. I don't think from, I think for.
Why?
Well, I'm glad you asked.
It's going to be another 5 minutes.
No. So to my mind, from kind of implies extraction. So if we're taking some things out of something and converting, then that might be a from. We might take the address from a customer record, for example. But that's not quite the same thing as conversion, it's extraction. Yeah. So for me, for.
Very subtle. I might learn this one day.
Okay, so we've got rid of the prefix this. It's now readable, but there's a problem, and that is that dbconfig is unused. So the compiler's lying to us. Well, I mean,
basically,
not lying.
We want this, right? But we want to refactor this.
Yes. So that's where we want to be, but we're going to be a bit sort of Flash and refactor our way into that.
Okay. That's the plan.
And so instead of doing that edit, fast and beautiful it was, we're going to introduce we're going to introduce another scope function, a scope function. Have we introduced scope functions yet? No, I think we're about to. With.
Yeah, okay.
So if we say with dbconfig, then we can set up a block in which dbconfig is now this. It's the receiver. And if we're really smart now, we can basically say, well, if I had a data source that was this, so I have a val data source.
Sorry, what am I doing?
Oh, sorry. No, you're right. Val db. What are you doing? So we're going to say.
Can we move this up there now?
Let's try moving that up there. Yes.
I think that's the.
Oh yes,
that's
perfect.
the safe transformation.
That was all we
That
needed
kind
to
of
do.
shadow. Yeah.
Because now what we've done is we've taken this.
Actor. In this video, I won't go through any of those. I'll say the latest stable version is 2.4.5, so which means we don't actually get the first method that I want to.
bits that we didn't have, and we've this is now dbconfig in this class, in this function. Okay, so
to show you is simply how to create a mono, and to create a mono inside this function is dead simple. All we have to do is we type in the word mono and the method over here. And the first method that I want to show you is simply how to create a mono. And to create a mono inside this function is dead simple. All we have to do is we type in the word mono, and then there's a method called just, in which we can pass through the value that we want to receive. And then the only thing we need to remember to do if we're creating a mono is to use the subscribe method as mentioned in the blog. If you don't use the subscribe method, nothing will actually happen, and the mono is lazy, so which means we don't actually get the data out. So if I simply run that test now, what you'll notice is that everything is fine, but we don't see very much in the console, so we don't know what's happened or even if it's worked. One useful method in working with publisher types from Reactive is to use the .log method, because it will show us all the lifecycle events that happen when we subscribe to a publisher. So if I rerun this example now, and I click on that, we actually get to see all the methods that were called. And if you read the blog post, then this will make complete sense. You'll notice that the first thing that gets called on our mono is the onSubscribe method, in which an implementation of a subscription interface is passed as a parameter. We'll notice that there is a there's a method called to the request method, and we see this value unbounded, which again, as explained in the blog post, means that the subscriber is requesting an unbounded number of things to be sent to it. In the case of a mono, that will only be a maximum of one item, and that's how we can apply the back pressure mechanism using the reactive library or project reactor. The next method that gets called is the onNext method, passing in the value that we used inside of the just method. And then finally, because a mono can only send at most a single element, we'll notice that the onComplete method is then called to end the subscription between the publisher and the subscriber. And that really is the simplest way in which you can create a mono. But that's not particularly useful, so what you might want to do next is actually pass a parameter into the subscribe method so that you can actually do something with the value that is passed in the onNext method. The simplest way of doing that is simply to add a single parameter onto the subscribe method, which in Kotlin, because it's a closure, I can just omit the round braces and write the closure immediately over here. So now I can just do something like and use the single parameter passed into this closure as my single argument inside of this closure. And if I rerun that example now, what we should notice is that when we look at this, we see the same lifecycle methods happening. you can see that I've now received and handled the value that I got from the onNext call. In this case, I'm just printing it out, and then as before, the onComplete method is called. Of course, I can also run some code that should happen when the onComplete method is called using the subscribe method. And for that, I just need to increase the number of parameters I pass to my subscribe method. So let's do that now. So the first thing I'm going to do is I'm just going to surround these with the normal function call braces because I'm going to pass in multiple arguments. So I'll still leave this first argument in here to handle the value I get on the next call. The next value that gets passed through is the error consumer, and I'm not interested in the error consumer. In this case, I'll just pass in null, and then finally I'll pass in another closure. In this case, the type of this closure, in which I'm just printing the value done. And that really is all there is to handling values and being able to write some code that executes when the subscription is completed using. The way we would do that is we would simply start again with the factory call on mono. In this case, we'd use the function call of empty. Because there's not enough information for Kotlin to be able to determine the type, it'll give me an opportunity to specify that type. In this case, I will just use the word mono, and as before, I'll use the log method so that we can see what's going on, and of course nothing will happen if I don't create a subscription to that call. So if I now run this code, what we should be able to see is that the same lifecycle method gets called. It's the onSubscribe method. In this case, the implementation of the subscription method is this empty subscription. You can see the call to request still happens with an unbounded number. And of course, because this mono is empty and doesn't emit any values, we don't get any call to onNext, but simply a onComplete call that, as you've seen before, we could handle by passing in a runnable to our subscription method as the third argument. Okay, so you might be wondering why you would ever want to create such a thing, and is 0 simply a subscription that returns the B. You can try and run it. Again and see if we get the same result. And we're lucky enough that we firstly saw the empty one, and this time we see that we do in fact get a mono that emits a single value, which is the value that was passed in. course, there's something more that you can do with an empty mono rather than something like this. We can actually change the mono to provide an alternative value if the mono happens to be empty. So if the subscription unsubscribe method is called monos, the final thing that I've emitted. Okay, and then once I've created that exception, I can go through the normal. behavior of logging it, and then I can give it a subscribe method. In this case, what I want to do is I want to not pass in a handler for the first argument, which will be the consumer that gets called if a value is emitted. And then I want to pass through a second argument, which is the error handler. In Kotlin, I can move that second argument outside of the braces to make it a bit clearer. And I can say something like something like that. And if I now run this code and I look at that, we can see that it starts off the same. You can see that the onError method is invoked, and we can see that the error comes out, and something like that. And if I now run this code and I look at that, we can see that it starts off the same. You can see that the onError method is invoked, and we can see that the error comes out, and we can see that we get the stack trace for the exception, and then finally we can see that the value I've printed in my error handler gets printed to the console. Now you might be wondering what would happen if I changed this from a runtime exception to a checked exception. Do I then need to wrap this in a try-catch block? And the answer is no. In reactive types, we don't use the try-catch mechanism. So if I change this to some kind of a checked exception, like just the exception itself, and just so that we can see the difference, the mechanism is exactly the same. So I don't use the try-catch mechanism. I still use the subscription method and pass in a handler, and I pass in a handler for the exception that gets thrown, and you can see the behavior for a checked exception is exactly the same as it was for a runtime exception. So there's no need to ever use the try-catch mechanism with reactive types or reactive publishers. Okay, another thing that I can do is I can provide a different value if an error does occur while trying to get a value. So I'll leave the creation of that exactly the same as before, and what I will add to this is an onError resume. And now what I get is an opportunity to apply an alternative mono to the one that I was expecting when the error occurred. So in this case, I will just use the just method again, and I will provide a value to this, and I will then perform the log, and I will perform the subscription as before, otherwise nothing will happen, and it's still complaining because I'm saying that this mono over here is expecting an error, but what I am actually returning is a mono of type string. So I have to change the type over here from error or from exception to string to make all of this work. And if I run that now, you'll see that what you get is the same lifecycle methods, but this time you don't see a stack trace. I've effectively swallowed that exception that occurred and replaced it with an alternative value that provides provides just the